So, hello dear students, welcome to the live session of the new class of electricity, and today we will discuss about the part 4. Today we will discuss about the electricity and power of the electricity, and then we will do some MCQs, solve some MCQs today. Okay, so do hurry and join the class. So, today this is our motivation. So today's motivation is time is non-refundable. So spend it on your dreams, not on distraction. If you distracted once, then the time didn't come again. So you will never find enough time to do everything, but you will always find enough time for the things that matters most. So you have to choose wisely which is important and which is the less important for you. So live purposefully. Okay, so today you plan, then focus, then learn this, and the most important thing is the discipline. And today is the perfect time for you to decide your future. Okay, so use time wisely, stay focused, study smart, build consistency for achieving the greatness or your goal. Okay, and today is a very special day for the first. This is 2026 International Yoga Day, that is World Yoga Day. So, for stay healthy and stay happy, you have to do yoga every day for minimum 20 minutes per day. Okay, so this is the World Yoga Day. And today is a very special day for everyone because this is the Father's Day. Every dream begins with a father's belief. Okay, so happy Father's Day to all the fathers of yours, and make the day special. And now we have to go for the session. And this is the class 11 semester 1 digital learning package. If you have any your elder brother or sister, then share this news to them that Science and Arts group in our Eduins, and subscribe our YouTube channel Eduins Higher Secondary. And this is for the West Bengal board students. Now, this is the electricity we have to discuss about. This is electric power. Electric power tells us how fast electrical energy is consumed. So this is formula of P is equal to VI. Okay, the formula of power is V into I. That is the voltage or potential difference and the electricity, current electricity that is flowing through the circuit. Okay. So this is the formula of the power. P is equal to VI. And from this we can derive other formulas that doesn't contain the V or I. So when P is equal to VI, we have to solve the numerics, right? Now when P is given and I is given but there is no V but R, then what will you do? Then this is the new derivation of this formula is P is equal to VI. We all know that, but here the main point is the Ohm's law. From this we get the V is equal to IR. Okay, so from this we can derive it like V. So at the place of the V, we can write IR into I, so that is the I square R. So this is another formula of power when the resistance and the current is supplied, then we can evaluate the value of the P. Okay, so and when V is given and R is given, then also we can calculate the value of P. But how? P is equal to VI. So from Ohm's law we can write V by R. So P is equal to V by R. That means V square by R. This is also another formula of the power. So these three formula, from where we can calculate the value or evaluate the value of the power of the electric circuit. Okay, and the unit. Now we have to derive the unit. Okay, so when this is electric energy, this is the power. Now we have to derive electrical energy. That is energy and power. When electric energy is, we know that power is energy by time. So for energy there is power into time, P into T. That means from this we can get it. And now the power, unit of the power. Unit of power is watt. Or we can write for bigger unit kilowatt. That is from 10 to the power 3 watt. We can get it kilowatt. Okay. So this is the kilowatt, and we can evaluate megawatt from this. So this is the unit of power. For the unit of energy, so we have to multiply it with the time when the power is used. Now E is equal to P into T. So for this, the SI unit of the electric energy is and P into T. That means P has the unit watt and the T is second. So watt second is the SI unit of the electric energy. So SI unit of electric energy is watt second. Now the BOT, concept of the BOT, that is board of trade unit or 1 unit. Okay, so this is board of trade unit. So for this derivation, we have to take the unit as The power of the unit is kilowatt and the time is in hour. So from this we can calculate it 1 watt second to the kilowatt hour. So for 1 BOT that means 1 kilowatt hour. So from this we can calculate it, right? 1 kilowatt that means 10 to the power 3 watt. And for 1 hour we have to calculate it in second. So for this watt second 3600 second. So 36 into 100 into 10 to the power 3. So from it 36 into 10 to the power watt second. So this is equivalent to 1 kilowatt hour or 1 unit or 1 BOT unit, board of trade unit. So for each unit we have to calculate 1 kilowatt hour. Okay, so that's how we can solve the numerics. Okay. Got it right? So from this we can calculate the unit consumption of a household electric circuit. So for this we can calculate this by the formula, that is we use the charger of 33 watt. Nowadays it's converted into 60 watt also. So we know that 60 watt charger. So what is 60 watt? That means this is the electrical power consumption. So this is the 60 watt. And from this we can calculate the values of the volt or the resistance. So when a star rated or a bulb shows that 100 volt and 60 watt, so that means we can calculate the maximum current flow through the circuit and the resistance of the bulb and the watt power and the voltage also. So from where we can derive it? So how we can derive it? So let's solve it and check it together. Okay, we all know that P is equal to VI. So here V and P is given. So for this equation, P is equal to VI, the P and V is given. Now we have to calculate the I. So from it, we can calculate it. P is equal to 110 volt. P is equal to 110 volt and V is equal to P is equal to 60 watt and V is equal to 110 volt. So from this I is equal to P by V. So 60 by 110, that is 6 by 11. So 5454, we can write it like 0.54 ampere. So we can calculate the maximum current that can passes through the circuit. For more current, this circuit can be made the short circuit or catch fire. Now for the excessive current flow, so this is the point or the maximum current flow here. Okay, 0.54 ampere. And from this we can calculate the resistance also. From where? From the formula P is equal to V square by R, or the formula P is equal to V square I square R. So from this we can calculate it. R is equal to, so from this equation we can write R is equal to V square by P, and V square is 110 and 110 by P is 60. So from this we can calculate it. Okay, 1210 into 6. So So 201.6, so something approximately 200 ohm. Okay, so that's how we can calculate from this information. So this is the information given in any kind of electrical circuit or the electrical appliances. So from this information we can evaluate the value of resistance, the value of maximum flowing current through it, and the value of the power and voltage also. So that's why this is given, the information is given for that reason. Okay, now this is the topic we covered. Now we have to solve some MCQs for this chapter. Okay, so the first MCQ is, okay, SI unit of electric current is. So at the previous class we discussed about all of these electric current, resistance, okay, power and potential difference. So this is the first question. SI unit of electric current is. The four options are volt, ohm, ampere and watt. So what will be the answer of this question? So anyone from the comment section can answer it. So for the first question, SI unit of electric current. SI unit of electric current, that is I. We all know that the SI unit of the electric current is ampere. Okay. Now, SI unit of resistance is. So for resistance, what will be the SI unit? Option A is volts, option B is ohm, option C is ampere, option D is joule. So what will be the answer? तो इनमें से आंसर क्या होगा? And for your information, today the live class is the science, and for tomorrow at 6 p.m. you will have the geography class. Okay, so this is the schedule for tomorrow's live class. Now, SI unit of resistance is. तो रेजिस्टेंस का SI यूनिट कौन सा है? इनमें से चारों ऑप्शन में से एक है वोल्ट, ओम, एम्पियर और जूल. कौन सा है? देखो इनमें होगा ओम, एंड इसका साइन कैसा होने वाला है? Like this. Okay, this is the sign of the ohm. Okay, now the second question and the third question. देखो, resistance of a conductor depends on. So at which factor it depends? So the first factor is length, the second is area, and the third is material, and D, all of these. So what is the main factor, or what is the factors that conductors depend on? And resistance of the conductor depends on length, area, material, or all of this. Anyone from the comment section? So we know that we know the relation R is equal to rho L by A, and L is the length, A is the area, and the resistance is depend upon the material of the conductor, and also rho. Rho is the resistivity. Rho is the resistivity. So for it, we can answer it like length, area and material. So the answer will be all of this. So resistance depends on all of these three factors. Okay. Now the next question. Current is measured by voltmeter, ammeter, galvanometer or thermometer. So current is measured by. So which device? We can measure current by which device? Is it voltmeter or ammeter or galvanometer or thermometer? What will be the answer? Okay. Current is measured by the ammeter. Current is measured by the ammeter, and always the ammeter at series combination of with the circuit or the conductor about which we have to measure the current. So this is the ammeter, and for the ammeter we have to take low resistance. So for this ammeter has the resistance approximately to 0 or about to 0 ohm. Okay, so this is a adding information. Now potential difference is measured by. So potential difference, the potential of two terminal point and their difference is measured by which meter? Ammeter, which device? Ammeter, voltmeter, ohm meter or fuse. So what will be the answer? What will be the answer? Okay, so the answer is voltmeter, and the voltmeter is connected with the circuit in parallel combination, and for this the resistance will be the maximum value. Okay, to infinity. The resistance must be infinity for the circuit where the galvanometer is connected in the parallel combination. Okay, now the next question. Fuse wire has high melting point, low melting point, no resistance, infinite resistance. So, which is the characteristics of a fuse wire? High melting point or low melting point or no resistance or infinite resistance. Okay. There will be two options correct. So from these you have to choose those right two options. So for this, anyone can give the answer. So do comment in the comment section if you know the answer. So fuse wire connected with the main source. Okay, in the series connection. So fuse is connected with the main electric supply of our household with the series connection. So this is the fuse wire. So for this, the current will be passed throughout the fuse wire. Now, if the fuse wire has low resistance, okay, fuse wire has low resistance. So when the value of the resistance decreased, then the value of the current flow will increase automatically. So, for overflow of current or increasing in current flow can hamper a circuit or destroy the circuit. So, for this, we can have the low resistance. So, fuse wire must be in the infinite resistance or high resistance. We have to answer it with high resistance. And the other is, if the wire This is the circuit breaker or circuit joiner. Okay. Now this is the fuse wire. This is the fuse wire that connected in the series. Okay. So this is the fuse wire. Now, if the fuse wire having high melting point. Okay. High melting point. So we all know that from Joule's law. From Joule's law, H varies I squared RT. So they produced heat. Then if the wire has the higher melting point, then if the flow of current increases, they produced heat, and by the heat the fuse wire must be melted. But for high melting point, the fuse star does not melt. Okay, so for this, the circuit and the electrical appliances that connected through the circuit or the main source of the line that can hamper or destroy. For this, we have to take low melting point, the wire that contains low melting point. For the low melting point, when they produce heat for the excessive current flow, the circuit melted and the circuit becomes an open circuit. There is a discontinuity, and for this the appliances will be saved from the high electric flow or the short circuit. Okay, so that's why we have to take the fuse wire as low, that has low melting point and has high resistance. So there is not infinite resistance. So for if we take infinite resistance, then there will no current flow through the circuit, and we can get the desired current flow through the circuit. Then the brightness of the light or voltage of the fan can be decreased. So we need high resistance, not infinite resistance. We need low melting point and high resistance. Not infinite resistance. Okay. Okay. So now the next question. A charge of 60 coulomb. A charge of 60 coulomb flows through a conductor in 12 seconds. Then the current is 3 ampere or 4 ampere or 5 ampere or 6 ampere. So we have to evaluate it through the numeric section. Okay, so charge of 60 coulomb flows in 12 seconds. So this is the formula. We have to use the formula. Q is equal to IT. So from it, I is equal to Q by T. So Q is 60 coulomb and T is 12 seconds. So the answer will be 5 ampere, because we used all the SI units. So coulomb is also SI unit and also the second is SI unit. So for this we get the ampere, the SI unit of the electric current. So option C is the correct answer for this question. Okay, got it? Now, resistance of a wire with 12 volt and 3 ampere current. So for this, the potential difference and the ampere, that means the current flowing through the circuit, is given. Now we have to determine the resistance. So for the resistance we have to use the Ohm's law. So from Ohm's law, we get that the formula is V is equal to IR. So V is the potential difference of the two terminals of the conductor. So V is equal to 12 volt, 3 ampere current. That means I is equal to 3 ampere. And we have to calculate the resistance. So from this we get that R is equal to V by I. So from it, R is equal to V 12 I 3. So in ohm, because those are in SI units. So 4 ohm will be the answer. So the answer will be 4 ohm. Okay, got it? हाँ ये लाइव है समर्थ. This is the live class of electricity, Samarth. So, the next question is, power of a bulb operating at 220 volt and 2 ampere. So they're giving the potential difference 220 volt and the current flow 2 ampere. So we have to derive the value of the P. So anyone from the comment section can give the correct answer. So what will be the answer? Anyone from the comment section? So Samarth, can you give the answer? Or can you answer the question, Samarth? So from the equation of the power, P is equal to VI. P is equal to VI. So V is 220 volt and I is 2 ampere. So there is those units are in the SI. So for this the power will be in the SI unit, that is watt. So इसमें क्या है कि 220 वोल्ट है और 2 एम्पियर करंट फ्लो है. सो P इज इक्वल टू VI. इसमें अगर ये वैल्यूज दिया जाए तो ये यहाँ पर क्या आंसर आएगा देखो 440 वाट. सो दिस विल बी द आंसर. सो यहाँ पर आंसर क्या आने वाला है कि 440 वाट होने वाला है इसका आंसर. तो यहाँ तक समझ में आ गया सबको. तो चलो अब उसके बाद क्या क्वेश्चन है हम देख लेते हैं कि 2 रेजिस्टर्स है. इनमें से एक है 2 ओहम एंड द अदर इज 4 ओहम. ओके, दे आर बोथ इन द सीरीज कॉम्बिनेशन. दे आर बोथ इन द सीरीज कॉम्बिनेशन. तो देखो इसका इक्विवेलेंट रेजिस्टेंस क्या होने वाला है. तो इक्विवेलेंट रेजिस्टेंस फॉर द सीरीज एंड द फॉर द पैरेलल, there are two type of equation. So for series we know that R is equal to R1 plus R2. For this is the series, and for the parallel combination we got the equation like 1 by R1 and 1 by R2. So the two resistors are in 2 and 4 ohm in series. So this is a very easy question for you. Two resistors 2 ohm and 4 ohm in series. So इनमें कौन सा कनेक्शन है कि ये है सीरीज कॉम्बिनेशन में. सो इक्विवेलेंट रेजिस्टेंस क्या होगा कि R is equal to R1 plus R2, that means 2 plus 4, that is 6 ohm. So this is the answer. तो यहाँ पर आंसर क्या होगा कि 6 ohm है. ठीक है, 6 ohm. ओके राइट. तो चलो इसके बाद देखते हैं कि क्या क्वेश्चन है. चलो, टू रेजिस्टर्स. ओके, एक है 6 ohm एंड दूसरा है 3 ohm जो पैरेलल कनेक्शन में है. तो इक्विवेलेंट रेजिस्टेंस क्या होने वाला है इसका. देखो दो है, एक है 6 और अदर इज द 3. तो पैरेलल कॉम्बिनेशन में क्या होता है, हेलो So, can you give the answer? Can you answer the question? Anyone from the comment section answer the question? Of course, there is also math class. There is live classes of math. Another is 3 ohm. So R is equal to 2 ohm. So the answer क्या है देखते हैं. So heat produced if I is equal to 2 ampere, R is equal to 5 ohm and T is equal to 10 second, then what will be the heat? So from this question we have to derive it from the Joule's law of heating of electric current, heating effect of electric current. Okay, am I audible to you? Is this live is audible? So the answer is in the joule. So we have to calculate J as 1. So for this H is equal to I square R3, that means 2 square 5 into 10, that means 4 into 5, 210, 200 joule. Okay, so that will be the answer from H is equal to I square R3 by J. So from here we can calculate it. So this is the equation of heating effect of electric current and the law is Joule's law. Hello. Hello Chandan Kumar Arya. So now for the next question. चलो तो देखिए अगला क्वेश्चन कौन सा है अगला वाला. तो if length of wire doubles, resistance becomes. That means length of wire doubles, resistance become. So from the factor of the resistance, we all know the formula is R is equal to rho L by A. So the rho resistivity for a substance is constant for this metal or matter. For different material the resistivity differs, but for the same matter the resistivity is same for everywhere of the conductor or the matter. Now the length of the wire, so A is also constant and rho is also constant. Now if the length of the wire doubles, so resistance becomes, if A becomes L 2L, L becomes 2L. So now we can write it rho 2L by A. That means 2 rho L by A, and that is the previous resistance and the previous from, and the new resistance become double of the previous resistance. So the answer will be double. So the resistance becomes double. Okay, so this is the right answer. Okay. And now, next question. Now the next question. If a radius of a wire doubles, resistance become. Now from this formula we can evaluate it. So radius, that means the cross-sectional area. A is equal to pi r square. So for the radius, when the radius is doubled, then the cross-sectional area becomes pi r square. That means 4 times. So when we know that radius and the area, cross-sectional area depends on this equation pi r square. When the radius doubles, so the area becomes 4 pi r square. That means 4 times of the previous one. So area becomes 4th. Okay. So now r is equal to rho L by A, and we all know that L and rho is constant. But that means the resistivity and length is constant for that material. So for A is changes. Now R is equal to rho L by 4A. So this is the previous, and now R is equal to 1/4 of the previous resistance. So the resistance becomes 1/4 of the previous resistance. So that is the correct answer. So this is the correct answer. Okay. Now, the next one. Two bulbs of 100 watt and 60 watt connected to same voltage. Which has greater resistance? So, which have the greater resistance? So, the voltage is same for every of the watts or the bulbs. Okay, now P is equal to VI. Okay, and we all know that V square by R. Now, when P for the power for the first bulb that has 100 watt. Now 100 watt, that means 100 into 100 by, voltage is same for them. Now P is given. Now we have to calculate the resistance. So R is equal to, so that is R1 is equal to V square by P1. So for this, P1 is 110 and 100 and V square is same for it. So V square by 10 to the power 4. Okay. V square 10 to the power 4. And for the R2, V square by P2, V is same for both. So this is 60 and 60, and this is V square also. V square by 3600. So the value for the denominator is greater for P1, so value is less than the R2. So R1 is less than R2. So the 60 watt connection of the bulb has the greater resistance. So the 60 watt bulb. Okay. So commercial unit of electric energy, we know that kilowatt hour, that is commercial unit is kilowatt hour or unit or board of trade unit. Okay, those three are same. This is the answer, and this is few MCQs we have discussed in this class. So that's all for today's discussion. We will take the class at the next session. Okay, so this is the chapter electricity we have discussed at a few classes. Okay, so that's all for today, my dear students, and also thanks for watching, and do subscribe our YouTube channel Eduins CBSE if you like this live session.